So with the matching of subjects, as we talked about, they are used in the post-test designs and the pre-test, post-test control designs. So as we mentioned, you can match the participants on some characteristics such as age or test scores or the number of injuries they've had or body size, height. So the key is to usually only match on one of these variables, because if you try to match participants on age, a test score, body size, it gets very complicated. There actually are statistical matching based on how you think they're going to do on their dependent variable scores. Then they can be randomly assigned from pairs. I mean, that's probably beyond the scope of what we would do in the types of studies that we're doing. But this assumes that you can predict your dependent variable extremely well. Quasi-experimental designs. This means, and we touched upon this a little bit last semester, is when we are trying to fit research to real-world settings. So this is very common in our field where we cannot do random assignment. So school-based research, you have to try to control the threats to validity as much as possible. So we're going to analyze by the group, not necessarily by the individuals. So the matching design, so the M means that they've been matched on some characteristics. Then one group gets the treatment at the top, the other group gets the control, and then you test them just once. And then the pre-test, post-test, you have the matching on the baseline characteristics. You do a pre-test, you have a treatment and a control, and then there is some sort of another test. So again, better control of threats. It's not as strong as actually doing a random assignment, but anything we can do that's going to improve the strength of the study is good. I mean, there is no perfect study. We can't do every possible combination. Countervalence designs, so each group gets all the treatment with random assignments. So, somewhat similar to what Mallory's going to do, but these are multiple groups. So, like, say she had a group of athletes and a group of non-athletes, and those would be our two groups. So, she'd have the non-athletes do pre-test, and then they would do another one, and then they would do another one. So, you have to do a washout period. This is pretty common in sports nutrition research. In fact, I've done something very similar for my dissertation, and that there were, multiple observations, and the participants were randomly assigned into groups for their different treatment beverages. So it's very common in sports nutrition and other nutrition research is that you'll randomize the different treatments, and so they'll cross over, and so everybody does everything. Time series, kind of an extension of the one group pre-test, post-test. As you can see, you do multiple baselines. So you do an assessment 1, 2, 3, 4. Then you implement your treatment, and then you keep on doing post-assessments. So you can see that there's a lot of problems with that, and that people probably are going to get pretty annoyed that you're keep testing them all the time. So, and that there are testing effects. They may just do better on the test just by virtue of doing the test multiple times themselves. Or if you're dealing with something, say like an athletic injury, such as an ankle sprain or other injuries, the history issue in that they just may get better on their own without any effect of your intervention. So what we're going to move on to are factorial design, so analysis of variance, abbreviated ANOVA. And so this is where we're going to start to get into manipulating independent variables. So one independent variable, we have what are called main effects. So by group, by time. So we're going to look at the column mean and the row means, and we're going to test the independent variables when the others are all held constant. So fixed effects are you choose the groups, random effects, you randomly selected the group. So either one of these is considered a strong effect. And then really what we're looking at the bottom of the slide is looking at this group by time interaction effect. So most of the times that everybody changed is not that interesting, but the fact somebody changed by condition is usually what we are looking for.